Okay, so we have that part that we can write the number 1 in so many ways. This, if you don't remember this one's here, remember what I said, you take sin square theta plus cos square theta equals to 1. For you to have something in terms of second, that is the inverse of what? Cos, divided out by cos, and then rearrange that. So for example, if you have sin square theta plus cos square theta equals to 1, if I was to divide throughout by sin square theta, right? In this part, it's going to be 1. Here it's going to be cos over sine, it's going to be what? 10 square theta. The inverse of sine is what? The inverse of sine is what? Cos x square theta. So we want that 1. So when you move that over, 1 equals to cos x square theta minus 10 square theta. So this is exactly the stuff that I put here. Okay? Does that make sense? The other one there? Cos x square theta.
That one is cos, sir. It's not 10. It's not 10.
This is cos over, so this is supposed to be what? Cot. Anyway, again.
Exactly.
Alright. So basically comes from that, and then you start again, you might cos square theta. The subject of the formula is but number 1 can be written. This ones, first of all, are very easy to do. The ratio multiplied by the inverse is equal to cot times tangent. Cotangent times cot gives you that. Alright? And then this one you should be able to find. So you should make sure that when you are dealing with these identities that you're seeing. But this is the part I want to focus on, the equations. Whenever you start a topic, you need to be able to find what is it that we need to do. The same way when I gave you the summary of the things that you need to do when we're dealing with identities. Right, so you will be now solving equations, Trig equations. You will also find that, because sometimes you might give the equations in terms of cos sec, for example, and also some square stuff. So I can give you, like, the way I can give you an equation like this: sin square theta equals to, like, 1 over 4, right? Sin square theta equals to 1 over 4. What does it mean? If you need to get rid of this square, you need to take the square root of both sides. So if I give you a domain between 0 and 360 degrees, you would be saying, wait a minute, sin theta will equal to plus minus square root 1 over 4. So therefore there are two possibilities. There's going to be sin theta equals to 1/2, or sin theta equals to negative 1/2. So you are going to look at which quadrant is sign positive and which quadrant is sign negative. In fact, this is going to be the solution to all 4 quadrants. You understand? So this is going to be when that is positive. So this is going to be your reference basic acute angle. Is going to be the angle of sine inverse of 1/2. Right. The angle of sine inverse, remember, that is your 30 there. So this is 30 degrees. So one solution will be 30 degrees. That will be in which quadrant? In the first quadrant. Okay, so when you are looking at here, the ratio, when that is positive, that is in the first quadrant as well as in that quadrant. So the 30 degrees is in the first quadrant. In the second quadrant, it's going to be 180 minus that 30 degrees, which gives you 150 degrees. Naturally, if this is the sine curve, alright, this is the sine curve. So this is 360 degrees, and that's 0, and that's y, that's 1, and that's negative 1. The ratio of 0.5 will have solutions in the first quadrant as well as the second quadrant. That is the 30 degrees and that is the 150 degrees. This here is 180 degrees. But there are also other 2 solutions when the ratio is negative 0.5, negative, like we have it here. So we are looking for those solutions as well. That will be in the third quadrant, the sign is negative, and in the fourth quadrant, the sign is negative. Here we're going to add. So we are using our basic angle there. of 30 degrees, and then you find that particular answer. So it's going to be 180 plus 30, which is 210 degrees. And the other one will be 360 minus 30, which is what? So the solutions to something like that would be, theta would be 30 degrees, 150 degrees, 210 degrees, as well as 330 degrees for the given domain between 0 to 360. Cool? There is going to be parts where the stuff on this side becomes quadratic, which means you must now let it equal to 0. And you create that quadratic. You follow? There's going to be the basic ones. And then when you are given angles in ratios, when you are dealing with the domain is given to you in radians, for example, 0, so that's theta maybe, to pi or even to 2 pi radians for that matter. Then your angles must be given in radians. Remember in the beginning when I was saying that some students, they are liking to work with the change it and all to, but now you should be familiar on how to deal with radian measurements. Does that make sense to you? Okay? So when you get an answer or something involves you to have radians, you must always change the mode now on your calculator to radian mode, because you are now going to solve for that particular measure. So in this quadrant it will be that theta. In this quadrant it will be pi minus theta for radian measurement. In this quadrant it will be theta plus pi or plus pi plus theta. And in this one here will be 2 pi minus theta. So the angles is not really, the equation is not really that complicated, but it's when the domain is restricted, like what we did, blocked out certain things. And also when you are now given it the angles in terms of cosec squared is equals to that, stuff like that. And also it will involve you maybe to take out common factor as well, and quadratics, and stuff like this. And anything to the 4th power is just a hidden quadratic. 4th root of that. That is the overlay of how it's going to work. Okay, so you have got that note on page 191 right at the bottom, and I would want you to highlight that one. It says when the question gives angles in radians, that is between 0 and 2 pi radians, basically the stuff that I just mentioned, the answers should be given in radians. So you must make sure that your calculator is set in radian mode. Check the mode, please, of your calculator, the display mode. Okay, R or RAD. So the first ones, they are basic. Okay, 9 out of the 8 is basic. So we're going to look at just 3 of them randomly. Is it fine? So we start off with basic stuff. It says solve the following equations, and the domain is given for theta between 0 degrees and 360 degrees. So for the following one, theta is between 360 degrees and 0 degrees. So I'm going to take them randomly. So maybe I'm going to take the one sine theta equals to root 3 upon 2. Do you remember what that angle will be? Do you remember the right angle triangle? The height was root 3. The 2 was the hypotenuse. The height was root 3. The 2 was the hypotenuse. What is the angle? 60 degrees. 60 degrees. The angle is 60 degrees, right? But you can calculate it. Since it's degrees, make sure your calculator is in degree mode, right? And in which quadrant is sine positive? It's positive in the first and in the second quadrant. So one of our solutions will be theta, one of our solutions will be 180 degrees minus theta. Does that make sense? So we say that theta is equal to, so our theta is equal to 60 degrees, which is the solution in the first quadrant. And then in the second quadrant, it's going to be 180 minus 60 degrees, which is what? 120 degrees. Nothing to be afraid of. So these are our 2 solutions. That makes sense? Okay. So please have a look at the domain. But for the questions that I'm doing here, firstly, the domain is going to be from 0 to 360. Right. If you can't recall the angles, please just use your calculator to find the angles. Is that fine? Right, so the next one that I can choose from there will be, maybe you get, I don't know, tangent theta equals to minus 3, comma 4, 8, 1. Again, in which quadrant is the tangent ratio negative? Here it's positive. Here is positive. So these are the particulars we're looking for. 180 minus theta, 360 minus theta. So we need to find our reference angle. And when we find our reference angle, we are going to simply say theta equals the inverse time of the positive. Don't take the negative, right? Of the positive is 3,481. Whatever that angle or that angle is, we are going to subtract 180 minus that angle. Then we're going to take that angle away from 360 degrees. Does that make sense? So when you get to one decimal place, make sure you calculate the degree. What is that to one decimal place? 74.0. Do we all agree? To one decimal place. Right. Always give angles to one decimal place. Right. But that's not our solution. Because for that acute angle, the ratio will be positive. Remember, you need to see the tangent curve, and you need to -3. Remember, the amplitude of a tangent function. The amplitude of a tangent function is undefinable. The amplitude doesn't exist. Oh, it's undefinable. The maximum doesn't exist. The minimum doesn't exist. So -3 is somewhere down there. You understand that curve? So actually, then in the second quadrant, we are going to have 180 minus 74.0. Then in the fourth quadrant, we're going to have 360 minus 74.0. So the two solutions will be, what is this answer? Don't worry, I'll wait. 108 take away 7 is 110. 110 take away 4 is 106. That's the solution. 0.0 degrees to one decimal place. Now, please tell me what that is, please. By the way, you should know that, right? 360 take away 60. That's 300. 300 take away 4. You don't know. That's 296. Does it take that long? Ah, 86. At least you got it. Eventually. People, when you are subtracting, please use your calculator because you are struggling, okay? First take away 70, then take away 4. First take away 70, then take away 4. Anyway, we should not have to struggle with that. It's basic. AS level students. So for that is basically all the other things are fine, sine, cosine, and you know how to deal with that. But let me just take cosine as well, because I did sine and I did the tangent ratio. So the next one is going to be, our third one would be cos theta equals to 0.456. Now, the ratio for the cosine and the ratio for the sine will be less than 1. Okay, hypotenuse is longer, right? This is also defined for this particular domain. In which quadrant is cosine positive? The cosine is positive in the first and that one. So 360 minus our reference angle, and our reference angle will also be a solution. Is that fine? Good. So let us find the angle there. So please make sure your calculator is in what mode? So please put inverse cos of 0.456.
1 decimal place.
What is the angle to 1 decimal place? What is after the 9? There we go. Now, this is one of our solutions there. So in the fourth quadrant, our other solution would be 360 degrees minus 62.9 degrees. Okay, 360 take away 60. 300. 300 take away 2. You don't know. 398. Take away 0.9.
Oh, it's just 8.9.
297 degrees. Is this answer and this answer within our domain? Is it within our domain? Good. I'm asking that on purpose. And cut. What is the time?